Now, after learning this much about the magnetic field, let us have a comparison between electrostatics and magnetostatics. For electric field, we wrote down the divergence of the electric field. We calculated this to be rho over epsilon naught. This is known as Gauss law. And the curl of the electric field was 0. And this has no name. This law has no name. In case of magnetic field, we have just derived that the divergence of the magnetic field is always 0. This law has no name. And the curl of the magnetic field is non-zero, is mu naught times the volume current density. And this law is known as the Amperes law. So, in terms of the divergence and the curl, electric field and magnetic field behave oppositely to each other. And the electromagnetic force that we have calculated, that we have found out, is Q E plus V cross B. This is what we have learned about the electromagnetic force over a charge. So, here the amount of charge is Q, electric field applies on it, and the force is along the direction of electric field. Magnetic field applies a force only when the charge is moving with velocity v, and then the direction of the force is perpendicular to the velocity of the charge as well as perpendicular to the magnetic field itself. That is very interesting. So, we find that electric field and magnetic field, they do not behave similarly to each other, and because we had curl of the electric field going to 0, that let us define a scalar potential.